Okay, 28 is write the negation of the conditional using the formula. Okay, and the in word is writing word. If no, it is raining. And because it's conjunction and you negation do not take your coat. And this corresponds with the option A. Okay, 29 is proof somehow this statement negation P conjunction negation Q is equivalent negation P disjunction Q using truth table. So this is a four combination. We have negation P is completely opposite true value is false, false, true, and true. Negation Q is false, true, false, and true. Now, negation P, conjunction negation Q. This is only true when the both are true, this column and this column. It's only in the last one. The rest is false. Now, P, disjunction Q, remember. This is true when at least one is true. This is true, 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 and false. So we're using basically this and this column. Now negation this. This completely opposite true value is false, 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 and true. And when you compare this column and this column, they are identical. It's saying that proof that this statement are equivalent. Okay, the contrapositive is the negation Q, but Q is IL pari. According negation is if, because it's a conditional. If I don't pari, comma, then I didn't pass. Okay, corresponding with the option A. Okay, in 31 you identify who is P and who is Q, because you write in more, elegant way to see the conditional statement using if then. And now negation P is if it is not a cat, comma, then it does not catch bear. This corresponds with the option A. Option A. Okay, 32 is this statement, is conditional statement, and you find the converse. The converse is super easy. The converse, the only thing you should do is switching. So you change the antecedent for the consequent and the consequent for the antecedent. So the answer is negation P, conditional negation Q. Okay, corresponding with the Okay, 33 is find the inverse. The inverse is super easy because inverse is the only thing is negation both. In the same order, stay the same order, but negation. Negation of P, negation double negation is just P. Does this correspond with the option B? Okay. Okay, 34 is using Euler diagram to determine whether the argument is valid or invalid. Okay, not all. The first premise is not all the glitter is gold. Okay, not all is synonymous to say some. Entonces when it's some, the Euler diagram look like that. This represents glitter things, and this is represent the gold thing. The second premise say my ring is glitter. Okay, so there are two possibilities. You get X is here, okay, X is here. And the conclusion is my ring is not gold. It's not gold. For example, the first supposition is okay because it completed out the goal, but the second no. Entonces si at least one fail, the argument is invalid. Entonces the argument is invalid. Invalid, que es the option B, no? Invalid. Okay, super. Okay, and 35, using Euler diagram again, all cat live fish. O sea, es obvio que we have one big set que represent live fish. And inside, of course, we have a cap as part of this cups. Now, this is the first premise. The second premise is Henry is not live fish. Okay, that means Henry is completely outside the set of the live fish. Now the conclusion is Henry is not cat. It's obvious it's completely valid. It's correct. It's valid because never Henry is inside the set of the cat. This is valid. This argument is valid. Okay. 36 is using truth table to determine if the argument is valid or not. So we have the four combination PQ. Now let's proceed premise by premise. This is the first premise. It's this junction. This junction is true when at least one statement is true, and it's false when both are false. This is the premise number one. The premise number two is the negation. Is the negation of what? It's a negation of one. Okay, obviously it's false, 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 and true. Now after that, let's see the conditional formed by one conjunction negation one. Is always false, 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 and false. Now the conclusion is negation Q. Then the conclusion, let me call this number 2. Conclusion, okay, this is premise number 2, and this is a combination. Let me call number 3. Negation Q is false, true, false, true. Now 3 conditional negation Q is the conclusion. Let's see what happened. Also is this is false, Entonces always is true. It's always true because we need to be false here, true here, but it's never is true and false here. Entonces es obvio que es true always. This is tautology. Tautology. Therefore, the argument is valid. This tautology is true in every cases. The argument is